how I can get this to work. I figured it'd disappear. And I'll be out of the way in 1 second to try to give you a couple minutes to, or at least a minute or so to write everything down. Somebody would have their books out too and looking at these just to make sure, you know, just have a book sitting there so that somebody can check me to make sure that I don't copy anything wrong or write anything wrong as we're going through it. Let's see how this works. No. Daggone it.
Was it gonna shut down or something?
I was trying to. Which doesn't bother him a whole lot because he understands it. It bothers me because when I get used to it and then it changes, I don't understand it anymore. All right, later on in the year we're going to learn stuff about circles. On this circle, somebody tell me segment QT here is what kind of segment in relationship to that circle? QT. Or you could do QR, QY, QW. Come on now, it's an easy one. What is it? In relationship to the circle. That's the start of the word that I want.
Inside of it.
When you have a circle and you go from the center to the edge, what's that called?
Radius.
A radius. All right? Later on in the year, we're going to learn that in a circle, if I have QT as a radius, QR is a radius, QY is a radius, QW is a radius, guess what has to be true about all their lengths? They're the same. Well, instead of using that rule, and actually it's a theorem, it's another real short theorem that we're going to learn later on. It says all radii are congruent. Well, since you don't know that theorem yet, they just told you all four of those were congruent. So the first thing I'm going to do in this picture is I'm going to come in here and I'm going to mark RQ, and this is what I want you to do on your paper there. RQ is congruent to TQ, which is congruent to YQ, which is congruent to WQ. You're not going to understand any of this. So now, once I know that, as we're trying to prove triangles are congruent, last time we learned 4 shortcuts, 4 like blueprints or patterns or whatever you want to call them, to help you prove triangles are congruent. And I'm going to write them right up here. I'll probably have to do it on every screen. What's that one stand for?
Side,
Side. Good. How about that one?
side,
Just right angle mark.
Side, angle, side.
Forward.
I might hear in a minute.
Angle.
We skipped one. Angle, side, angle, and then
Oh gosh.
angle, side. If you get too close to that thing, it doesn't want to read it. So we got those 4 things. Well, looking at our 2 triangles here that we're trying to prove congruent, we already know one pair of what here? Sides. So that's a pair of sides. And then we know another pair of sides. So right now we have an S and an S. Is that enough to say that the two triangles are congruent? How many parts do we need to prove a triangle congruent to another one? 3 parts. 3 parts in every one of these, right?
Oh,
So we got a side and a side. Which two of these 4 could we be using? Side angle side. So it could be side angle side, or what's the other one? Side, side, side. So either we need a pair of angles or a
very simple.
pair of sides. We go to the next given. It says angle RQY is congruent to WQT. Are those 2 angles in our 2 triangles? Yeah. Now, you got to be careful when you're using angles, because remember, to be side angle side, that angle has to be between the 2 congruent sides, right? Is it? Yeah. So it's angled. That means we're not using that one. So can we prove these 2 triangles are congruent? Yeah, by using what? Side angle side. So we should be able to come over here and write our 2-column proof now. Statement.
Why didn't you just put S in there?
You can if you want. I wanted to write it out at least once, just to make sure everybody remembers what it is. We got our statements. For every statement, you have to have a reason. You have to tell why that's true. Now here you got to be careful with the way they listed this. What did I tell you about giving information when we were doing 2-column proofs? Split it apart. Don't put it all in one thing. Split it apart. All right? What's our first statement going to be?
RQ is congruent to PQ.
How do we know that?
Yeah.
That was given. Now, another thing that I think you ought to do on these 2-column proofs where we're proving triangles. Should have probably separated that a little bit. That's what we're trying to prove right there. Where we're proving triangles congruent is I like to come out here and in front of the number for the statement, put an S or an A if it's a pair of sides or a pair of angles in the 2 triangles. So on this one, I'm going to put a little S. The reason I do that is then when I get all 3 parts that I need, I'll know and I can go right to the triangles. All right, so I got a pair of sides. Is that enough to say the 2 triangles are congruent? No. Can I say any more stuff about those 2 segments being congruent? Not really. So where do I go to next? All right, so, well, YQ is congruent to, how do we know that? Guess what I'm going to put out here beside the 2? So I got a pair of sides, another pair of sides. Is that enough to say the 2 triangles are congruent? Now how many parts do I need? 3 parts. Well, where's my 3rd part going to come from?
That
Angle.
angle. RQY is congruent to angle WQT.
How do we know that?
It's given.
It's given. Guess what I put out here beside the 3? Is that enough? Now you got to be careful. Notice over here, when you go to write an English paper, do you just start writing your paper and hand that in and that's your finished draft? Not usually, right? Usually you probably make some little notes, then an outline, stuff like that. All this stuff over here that I did, this is like my notes. Notice I write stuff down over here so I can look back at it and refer back to it. Because if I get over here, is this in the right order? No, it says side, side, angle. Is that one of our 4 ways to prove the 2 triangles congruent? No, that's not even one of them. But it's just in the wrong order. We know it's in the right order over here in the picture, correct? So when I go to prove these two triangles, what am I going to use? Side angle side, not side side angle. Right? There's no such thing. So I have enough information now to say the two triangles are congruent. Then my next step is going to be to say the two triangles are congruent. With the homework you're going to do today, you're going to have to match up the triangles. Do we have to match them up here? They've already done it for us, didn't they? So all we got to do is write down that statement right there. Triangle QWT is congruent to triangle QYR. What's our reason going to be? Side angle side. And that's all you write over there, SAS. What's our next statement going to be? I hope you don't have any clue. Say it again. There is none. We're done. That's what we were trying to prove. Why would you want to go farther than what you're trying to prove? All right. Couple things I'm going to say on this real quick. If your statement, everybody listen close, if your statement is two triangles, that reason has to be one of those four things. It's got to be one of those four things. So if Justine still doesn't understand any of this, it's all confusing to her, could she still have a good shot of getting that right there correct? Yeah. What chance would she have? What are the odds that she's going to get it right? 1 out of 4, 25%. Just by guessing. Triangles as the statement, it's got to be one of those four things as the reason. Nothing else. All right? Now let's go through this real quick. If this was on a test, it's probably be worth 8 points.
Because all they're gonna be worth 2 points each.
Each statement and reason's worth a point each. All right? Should anybody miss this one? So that's 1 point. We'll just tally them up here. Should anybody miss this one?
No.
That's 1 point. Anybody miss this one? That's another point. Anybody miss this one?
No.
Another point. Anybody miss this one?
No.
Another point. Anybody miss this one? Another point. Anybody should miss this one?
Possible.
I hope not. It's right there as the proof statement, right? You know that that's got to go in your very last thing on your 2-column proof? Hopefully. So that's another point. Could you miss that one? Yeah. You got a 25% chance of guessing and getting it right at least, right? So, let's see. I forgot to mark one. So we got how many out of 8?
7.
7 out of 8. Plus, if you're a good guesser, you could get that last one right. To get 7 out of 8, does it take any brains whatsoever?
It just takes your hand out.
Just write it out. Given, given, given. The proof statement. I don't know what that is. Skip it. 7 out of 8. 7 out of 8 is like a, what is that? About a 80-some percent, 89% or something like that. All right. Everybody get all that copied down? Oops. All right, real quick before we go on, don't write any of this down. Look, it's not going to erase that now. Crap. If I give you a problem, got your statements and your reasons. There, Derek, are you happy?
Yes.
There's a problem on the next test. It's got 6 statements and 6 reasons. What should this reason right here be?
Given.
Should you be able to fill in this statement? What do you think this reason's going to be? Probably given also. You usually have at least 2 givens on every problem, all right? So you should be able to fill that in also. What's this going to be? the proof statement, right? Which is gonna be the triangle. Some triangle congruent to
No, Drake.
some other triangle. What's gonna be over here in the reason?
One of the four.
One of your one of four.
One of those four things.
Side, equals.
It's gotta be one of those four, alright? So, you don't even know what the problem is. This total of 12 points, you can for sure get how many?
Thick.
Close. 5. Plus, if you're a good guesser, maybe that extra one, right? That's doing nothing. 60%, or I'm sorry, 50%. I was thinking 6. 50%. And you don't even know what the problem is yet. All right? So if you just skip over these and do nothing on them, what's your percentage going to be? 0. Don't do that. These aren't that difficult. You just got to put in that little bit of effort. All right? All right, go ahead and start copying this picture down. New problem. I'll write the given and stuff in up here. Hopefully you can read my writing. How many triangles in this picture?
Right.
Does everybody see all 3 triangles? Now, when you have triangles that are like this, that are connected, overlapping, the very first thing you might want to do, and the very first thing I'm going to do every time, because I can't look at this picture this way, it confuses me. I know that you guys get confused, because Riley, you're all smarter than me, right? So you guys never get confused, but I do. What I do is I come up here, I read what we're trying to prove, and I split off those 2 triangles so I can see them separately. All right? This is triangle CDG. Got a G here, a D there. My D doesn't want to draw. And an E here. There. That D is supposed to be up there. So I split off those 2 triangles because I know that those are the 2 that I'm trying to prove are congruent. Now, they tell us, what's the first given information say? Triangle CDE is isosceles. What do you know about an isosceles triangle, Dustin? Say it. Did you hear that? Did you hear that? 2 of the sides are equal. Well, in the book, they told you which 2 sides. Normally, they'll tell you in the given information, it's isosceles triangle, and these 2 sides are equal, or this is the base, and we'll talk about that later. But they told us that these 2 sides right here are equal. Are those 2 sides in our 2 triangles that we're trying to prove congruent? Is segment CD in one of those triangles?
Yes.
Is segment DE in one of those triangles?
Yes.
So right now, we have a pair of, it's supposed to be an S, we have a pair of sides, right? Is that enough to say the 2 triangles are congruent? So then we go on to the next thing. G is the midpoint of segment CE. Clayton, what's a midpoint tell us?
The part of the halfway point through one segment.
All right, so remember this because we're going to have another vocab test coming up. If it's a midpoint, splits a segment into two congruent segments. So this segment has to be congruent to that segment. Is segment CG in one of our triangles? Right here. Is segment GE in one of our triangles?
Now you have two sides.
Sides.
So we have another pair of sides. So we have pair of sides, pair of sides. Is that enough to say the two triangles are congruent?
No,
No, we need something else, don't we?
you can get that angle.
Either we need
No side on angle.
a pair of sides or a pair of angles. The pair of angles would have to be these two angles right here, because they'd have to be between the two sides, so this angle and this angle. Next week, you'll know those two angles are congruent, so you can just use that. This week, you don't know it yet, so there's something else that we're going to use instead. What would the pair of sides be?
D and the DG and DG.
DG and DG. That doesn't make a whole lot of sense.
Because they share that one side technically.
Oh, they share that? So if they share that, what do you know about DG and DG? They're congruent. Now, what I want you to do, why are DG and DG congruent? Look in your notes from last time. Flip back one page of notes. We had a,
Reflexive property?
exactly, the reflexive property. You've got to remember this. Over here on the side, I wrote down reflexive property and vertical angles. These are things you got to be able to pick out with your head. All right? Because vertical angles are easy to find. When things share something, it's easy to find. It's got to be something you can pick out on your own. All right? So, and we'll make a list. We'll keep a running list of things. Hey, I'm going to look for this. I'm going to look for this. I'm going to look for this. You look for reflexive property. You look for vertical angles. Those are things that they don't have to give to you, that you can just come up with. Is that enough to say these two triangles are congruent?
Yes.
Yeah, by what? Side, side, side. Now notice, and I'm going to write this down. I'd probably write this also if I was doing it myself. We knew those two were congruent because G was a midpoint. We knew these two were congruent because the big triangle was what? Isosceles. So just to give myself some notes there so I remember to go back through it. What's our first statement going to be?
Again.
Given? G-I-V-I-P.
No. Angle CD.
What is it?
Triangle, not angle. What is an angle?
Triangle CDE is
Isosceles.
isosceles. How do we know that?
It's
It
given.
was given. Did that give us a pair of sides in the two triangles? Can I put an S out here beside the one?
Yes.
No.
That wasn't a pair of sides, was it? That led us to a pair of sides, and that's where we got to go next. What two sides did that lead us to?
D, C, and D.
Segment DC is congruent to segment DE. Does everybody understand that? Knowing that this triangle was isosceles, then we knew that these two sides had to be congruent. Anybody have a guess as to what your reason's going to be? I just said it. If what? The triangle is isosceles, then what do you know? Two congruent sides. If a triangle is isosceles, then you know it has two congruent sides. If my abbreviation in writing, if you don't understand it, please say something. So if a triangle is isosceles, you know it's got two congruent sides. Can I put an S out here beside this 2? Is that a pair of sides in the two triangles?
Yeah.
Yeah. So I put an S out there. Is that enough to say the two triangles are congruent?
No.
Now where do I go?
Yeah, but G is, midpoint of C, thanks.
G is midpoint of
I got that all mixed up.
segment CE. How do we know that?
Given,
G is a midpoint. Does that tell us two sides or two angles or anything? No, it leads us to something else though. As soon as we figured out G was a midpoint, what could we say? Anytime you see midpoint, then you know next thing you're gonna probably say is you have two segments that are congruent to each other. Because that's what a midpoint does. So, you went too far. If this is a midpoint, what two segments do we know are congruent from that?
G and G.
CG and GE. CG has to be congruent to GE. Don't forget that one, we're gonna use it here in a minute. How'd you know that CG was congruent to GE? What told you in step 3 up here?
G is midpoint.
Midpoint, and that's what we're gonna say. We're not gonna say G is a midpoint, so we're gonna make it like a generic saying. Midpoint does what? What's a midpoint do? Splits
Right now.
splits a segment, you make it harder than it has to be. Splits a segment into two congruent segments. Midpoint splits a segment into two congruent segments. When we take that vocabulary test here in a week or so, you're gonna remember when it says midpoint on there, hey, I know what definition is. Splits a segment into two congruent segments. Was that a pair of sides in our two triangles? So we put an S out there. Do we have enough to say the two triangles are congruent now?
No.
We got a pair of sides, another pair of sides. We're missing something. What are we missing?
That's why you're
Segment DG is congruent to segment DG. How do we know that segment DG was congruent to segment DG?
Reflexive property.
Reflexive property. What's reflexive property say again?
That when object reflects over itself, it's the same.
Anything equals itself. Anything equals itself. Reflexive property. All you're going to write right here, reflexive property. Please spell it right. It's not reflective property. It's reflexive. All right? When I do this, see how Riley had good reflexes? She blocked it from hitting herself in the face, from hitting her in the face. Reflexive. That's what that is. Not reflective like you're looking in the mirror. Reflexive. Anything equals itself. Was that a pair of sides or angles in our two triangles?
Yes.
Pair of sides. Do we have enough now to say the two triangles are congruent?
Yes.
So what's my sixth statement going to be?
Triangle CPG is congruent to triangle ECG.
How did we know that?
Side to side.
Side, side, side. Jaden, too hard? Let's go through this real quick. How many points on this if it's on the test? 12. Should you miss that one?
No.
That's 1 point. This one?
No.
2 points. This one? Yeah, you might miss that one. Maybe you don't know what a isosceles triangle is. Who knows? Well, if you miss that one, you're probably gonna miss that one too, right? Should you miss this one?
No.
Should you miss this one? How about this?
Maybe.
Yeah, maybe. Maybe you don't know what a midpoint is. I hope I've taught you something, but maybe not. Should you miss this one?
Maybe.
I wouldn't think so. If you miss reflexive property or vertical angles, I'll be bolder than I already am, all right? Because that's something everybody should be able to learn. So that you should be able to get 2 more points. Should you miss this one?
And the last one.
The last one, maybe you miss it, maybe you guess wrong. So you got what? 7 out of 12.
So they were about 60.
Better than 50%, right? That's knowing absolutely nothing. Not knowing what a midpoint is, not knowing what an isosceles triangle is, not guessing good out of the 4 possible things for that last thing. You should still get 7 out of 12 points, no matter what. Now, if we go through this, and the key idea here is, if you know this is isosceles triangle, what you're trying to do is whoever's looking at this next, they should know that, hey, these 2 triangles have to be congruent. So if let's do this. If I have this triangle and I tell you that this is 5 and this is 5, or let's just say you have some triangle, you're working on some triangle, you take this side right here and you know it's a certain length, and right in the middle you measure and you make sure those are the same, then that means that point right there is a midpoint, right? And if we know that this is an isosceles triangle to start off with, we know that those 2 things are congruent. Well, if I draw in the line going from this vertex, this top corner up here, down to that midpoint, what should be true about these 2 triangles every single time? They're going to be the same thing. They're going to be congruent to each other. This is where this stuff is used at. All right? You got some triangle, and you know it's isosceles, so you know the 2 sides are congruent. Well, if you can find the middle of this third side and connect it to the vertex, you know that this triangle here has to be exactly the same as that triangle there. And you can use that for different things, depending on what you're trying to build, what you're trying to do. All right, go ahead and start drawing this picture. I'll write the given and the prove statement in. The prove will be underneath the word prove because I messed up and didn't leave myself enough space. Let's see. This one's a little tougher.
And that's when it's 3 triangles, it's like 2.
As you're drawing that picture,
I think it's 5.
try to figure out how many triangles are in the picture.
5. That's my guess.
I was going to tell you to do that earlier, Dustin. But I thought, no, he's already upset with me enough because I'll just let him over there. But now I'm proud of you. Look, you see? Got a tear running down my face. I'm so proud of you. Took up some initiative, took it into your own hands. Said, you know what? I'm not seeing stuff well over here. I need to learn. That's what men do. Not boys, men.
Women.
And some ladies. Not Riley though. Everybody agree with Derek, 5 triangles in this picture?
Yeah.
I can't see
1, 2, 3. Where's the other 2?
The big
M,
one,
N,
the two big ones.
P, and then Q, N, P.
So, picture sort of looks like this, right?
Yeah.
That's what the picture sort of looks like. I know it's not exactly the same, but the 2 triangles that we're trying to prove are congruent are these 2. Now, if I try to mark this picture up the way it is right now, am I ever going to be able to do that for those 2 triangles?
No.
No. And this is where it is extremely important. I'm going to come up here and I'm going to split off triangle MNP. Doesn't have to look exactly like the first one. And this is what you should be doing on your paper. And I'm going to split off triangle QPN. Okay, my triangles don't look very good. That was horrible. So I split off those 2 triangles. Those are the 2 I'm trying to prove are congruent. Jonathan looks at the first given, and it says, this one they tried to make it tougher on you, make you think. It says triangle MRN is congruent to triangle QRP. And Jonathan says, hey, yeah, I don't have to do anything because we've already proven the triangles are congruent. Well, those are 2 triangles are congruent, but are those the triangles that we want to prove are congruent? No. All right? So the 2 triangles that they're telling us are congruent are these 2. This one and that one. Oops. So we know those 2 triangles are congruent. From that, if you know the 2 triangles are congruent, if I tell you these 2 triangles are congruent, then when I lay them one over top of each other, they should match up perfectly, right? So what's that tell us about this side in this triangle and this side in this triangle? They're the same. How about this angle in this triangle and this angle in this triangle?
Same.
They're the same. And that's what we're going to use that for. Looking at these 2 triangles, we don't care about these 2 triangles. We care about these other 2, but we can use stuff from these 2 to help us with those other 2. Do you see anything that these 2 triangles, the one on the left and the one on the right, that we could use in our 2 triangles to help us?
Well, technically, because it says that they're the same, that means.
Give me a couple segments or a couple angles that you know are congruent that's going to help us with our 2 triangles.
P is congruent to MN.
All right, stop right there. So this segment's congruent to that segment. Are those in our 2 triangles that we're trying to prove are congruent?
Yes.
Yeah, and if these 2 are congruent, we know that those sides are congruent, so we can use that up here. And when we get to that over here in our proof, I'm going to explain that. That's part of what we're going to do today.
Angle, RMN and angle RQNP.
So these 2 angles right here. Does everybody see that angle and this angle? They have to be congruent, right? Because they'd have to match up in those 2 triangles. Are those 2 angles in these 2 up here? Yeah. Now I'm not going to use them, all right? Because they actually gave us more information than we need here. So we could use that and put it in there as part of our proof. There's a whole lot of information. Are we going to use all of it? No. As a matter of fact, what do you know about these 2 angles right here?
They're congruent.
What kind of angles are they? They're vertical angles. Are we going to put that in our 2-column proof? No, because it's not going to help us get to where we're trying to go.
I'm confused here because aren't we trying to prove? I'm just really confused.
The big triangle, you see that big triangle?
Yeah,
And this big triangle, right?
yeah.
But they told us that this smaller triangle and this smaller triangle were congruent. So if those 2 triangles are congruent, they got to match up. What would we have to do to this triangle to get it to match up to this one? Flip it over to match it up, right? Well, if we flip it over, MN over here, this segment, would match up to what? That segment, QP. The triangles that we're trying to prove, MN and QP are in there. So if they're congruent in these two triangles, well, are they still gonna be congruent in these two triangles? So does that make sense, Clayton?
Yeah.
So we're just using parts from these first two triangles to help us with what we're trying to get to. So we have a pair of sides right now. What else do we have? What else did they tell us? Go back to our given then.
The angle MNP is congruent to angle QPN.
So MNP, that's this angle right here, is congruent to angle QPN, it's this angle. That's a pair of angles, right?
Mhm.
Is that enough to say the two triangles are congruent? Got a pair of sides and a pair of angles. Is that enough? We need something else, don't we? What else do we need?
We need another side.
Remember,
Another angle.
we have this, we have this, we have this, we have this. For that, what are we missing? We could use angle, angle, side. We could use another pair of angles that way, or we could use it that way, right?
Or you can do.
Or you could use side, angle, side. Let's look at that one first. Side, angle, side. Which side are we missing?
The bottom.
The bottom. So what is it? Name it for me in this triangle.
That's
NP.
Yeah.
What is it in the other triangle?
NP.
NP. Oh. What do you know about segment NP and segment NP? They're the exact same segment using the reflexive property. When I have these two triangles and they're matched up like this, when I pull them apart, what do you know about the length of this bottom and the length of this bottom? It's the exact same thing. It's the same segment, isn't it? That was by the reflexive property. I'm just going to put reflex there so I don't have to write out so much. So we know this segment's congruent to this segment. Is that enough to say the two triangles are congruent?
Yes.
Side, angle, side. Now, Derek had told us that these two angles were congruent earlier. I could have put those two angles in right there and right there. Instead of using side, angle, side, then what would we have used?
It wouldn't be right because.
Yeah, it
both
would.
sides would be equal.
Because then it'd be angle, side, angle. So is there a different way you could do this than what we're gonna do? Yeah,
That's kind of.
right? So there's all kinds of different ways you could do it, and there's probably other ways that we're not even gonna go into, because we have enough. One way's enough, right? Go through statements and reasons. What's our first statement gonna be?
Angle.
What is it?
Triangle. Triangle MR and it's congruent to triangle QRP. Jeez, I'm stupid today. Today is not my day.
How do we know that those two triangles were congruent?
Given.
Now, here in a minute, we're gonna write down something. And what we're gonna write down for today's notes goes along with this next step.
You have notes today?
Yep. Once you know those two triangles are congruent, what did we use from that? Once we knew this triangle was congruent to this triangle, this is what was confusing Clayton a minute ago. Once you knew these two triangles were congruent, we took parts from that to use on our other triangles, right?
Mhm.
What two parts did we take?
We took, angle
We can do the angles.
segment.
Segment what?
N, M, and P here.
So segment NM is congruent to segment
Today's not ready.
PQ.
Yes.
This segment was congruent to this segment, because if these two triangles are congruent, those two sides are gonna be the corresponding sides, the sides that match up, right? Our reason here is gonna be what your notes are gonna cover today. Make sure you spell this correctly. You didn't see the look on Dustin's face when he. What's it spell, Dustin? Everything spells that, hopefully. All right, CPCTC. This is like it's not a theorem, it's not a postulate really. It's like a rule, but we use it like a theorem or a postulate. And what it stands for? Corresponding, remember corresponding means the ones that match up, right? Corresponding parts of congruent, can you guess what T stands for? Triangles must be congruent. So in other words, this side corresponded to this side in those two triangles, and those two triangles were congruent. So those two sides have to be congruent. What I put out here beside the two? S? Now what? Where'd I go to next? The other given up here. Angle MNP was congruent to QPN. How do we know that those two angles were congruent? What do I put out here beside the 3? Is that enough to say the two triangles are congruent? Now we need something else. What else did we need? Segment NP is congruent to segment NP. How did we know that? Reflexive property. Reflexive property. What do I put out here beside the 4? Is that enough to say the two triangles are congruent? Do we have 3 parts? Yeah. So where do I go to next? Proof statement, the two triangles. Remember, let's do this on this one. We want those two triangles, but we're not going to name them that way. Name the triangle on the left up there for me in a different way, not in NP. PNM, I heard. And that's got to be congruent to, now you got to match them up. What's P going to match up to in the other triangle? N. What's N going to match up to? P. And what's M match up to? Q. You got to remember, you got to be able to match them up, right? On these two, I'd have to like flip this one over to match it up, right? Because part of what we're going to do today, you have to be able to do that. You have to be able to match up the triangles yourself. What's our reason? How do we know those two triangles? Side angle side. $10 points on this problem. Let's just count them up so I don't have to tally everything. Should you get this one? That's 1. 2. Maybe. We'll count it wrong. This one, 3, 4, 5, 6, 7. Yeah, maybe miss that one. 7 out of 10. 70%. That's knowing absolutely nothing. And you still got a 25% chance of guessing and getting that right. So write this down. You can title it. Let me get a different pen color here. Pen color. This stupid one. You can title it. What's that say, Dustin? Read it to me. Put, right? CPCTC, corresponding parts of congruent triangles are congruent.
What's today's date?
Today is the 14th. Corresponding parts of congruent triangles must be congruent. And we're going to write a couple of things down with this afterwards. Trevor H., can you remember that?
Yeah.
So what's CPCTC mean?
Corresponding parts of the congruent triangle are congruent.
Tongue twister.
cover it up, could you still remember?
No.
Even if you can't remember it, I'm going to tell you when you use it and how you use it, and that should be all you need to know. So even if you can't remember exactly what it means. All right, two things with this. Corresponding parts of congruent triangles are congruent. On these, I think two things. I'm going to remember one right now. On this, you're always going to use it only, oops, right, use only after proven triangles congruent. You can only use it after you've proven triangles congruent. So if you're looking at your two-column proof and you don't have in there somewhere that triangles are congruent, you can't use CPCTC. You've got to have said in there somewhere, these triangles are congruent, then it's going to go down to the next thing. The other thing, if your proof statement, so if you're doing a problem and it says prove, does that make sense to everybody? So I don't have to spell it out completely. And when you're doing it and it says prove, if it says segments or angles, now it's not going to say the word segment or angles. So an example, if it said prove segment AB is congruent to segment QR, if it said that, then you must use CPCTC in your two-column proof. All right? I know that probably doesn't make a whole lot of sense, but I'm going to explain it a little more here in a second.
Well, I thought you said we could only use it after we prove the triangle.
Right.
But then-
So what are you going to have to do? Know that you do first. Prove
the
triangles.
first, but then you have to
Then
go
you
back
can go
and
to
prove
that.
the
All right?
Wait, why would you want to try and prove the segment or angle after?
I'm going to show you. See if I got a free slide here. All right, don't write any of this down, but on this, let's say our problem looks like this. So our problem looks like this. Given, and you got a bunch of given statements here, all right? Prove angle Q is congruent to angle M. Just making up stuff, all right? Are we trying to prove triangles this time? No. But what you're going to have to do is go through and prove the triangles so you can get to this, all right? So your two-column proof is going to look like this. Statements, reasons, 1, 2, I don't know why I keep circling them. It'd be quicker if I didn't circle them. Say we got 6 steps, maybe, who knows? Again, you don't know what the problem is, right? All you know is this. Where's that going to go?
6.
What's going to go right here? All right? Here in step 5 is probably going to be some triangle is congruent to some triangle, because you have to prove the triangles before you can use CPCTC. Does that make sense now, Clayton? What's going to go over here in number 5? How do we prove triangles congruent? Side, 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 angle, or angle, angle, side. It's gotta be one of those four. Alright, still the same thing. You got triangles as your statement. Your reason's gotta be one of those things. So if you're looking at your 2-column proof, before CPCTC, what should be right above it every single time? One of those four things. If it's not, then something's wrong. Alright? So if you have this problem, should you be able to get number 1 right?
Yeah.
Yeah, because it's probably given, right? So that's 2 points. Number 2, probably given also, right? So that's 4 points. Maybe you missed 3, you missed 4. Should you be able to match up the triangles? Yeah. Right? If you're given the picture, you should be able to say, hey, I know this triangle and this triangle are the two that are going to be congruent, so you can match them up. 25% chance of guessing there because it has to be one of those four. We're not trying to prove the triangles this time, but you have to prove the triangles first to lead you to the fact that, hey, if these two triangles are congruent, then I know that these corresponding parts have to be congruent. Should anybody miss that one right there? No. If your proof statement is angles or segments, what's your last reason going to be? CPCTC. Should anybody miss this one? No, that's your proof statement. 1, 2, 3, 4, 5, 6, 7 out of 12 again. No matter what, should everybody get 7 out of 12 on that? Yeah. Now Riley, she's so intelligent, she knows she's going to get a lot more than that, right? 13 out of 12.
That's not very fair.
Real quickly, go ahead and write this down since I got it up here. This is your assignment tonight. We're not done yet, but that's your assignment tonight.
Okay, see if I can type it in.
Also, take a second once you write it down. Come up here, grab these 2 sheets. We're going to do some problems off of those 2 sheets. So just once you get it written down, take a second, grab those two sheets. Let's see here. Segment AE is congruent to segment FC. Segment AB. This is a good one to write down, so again, I'm not going to force you to write it down, but might be extremely helpful. Segment BE is congruent to segment BF. And we're trying to prove that triangle AFB is congruent to triangle CEB. How many triangles in this picture?
7.
7?
I got 6.
6?
Close at home. 6.
There's 6. Now look at what we're trying to prove. Because there's so many triangles in here, we need to separate them off so we can see them. We're trying to prove triangle AFB is congruent to triangle CEB. If I try to mark those 2 triangles the way they're sitting there, am I going to be able to do that without being confused? No. So what I'm going to do, I'm going to come up here and split them off. Now, do my triangles have to look exactly like they look down there? No. As long as you make sure Graham knows that, hey, it's just Mr. Eversole's ugly drawing. It doesn't have anything to do with the way the triangles actually look. All right, so this is A down here, B here, and F, and then this is E, C, and B up there. So those are the two triangles we're trying to prove congruent. Now watch carefully on this. The first one, they tell us segment AE is congruent to segment FC. Is AE and FC in those two triangles? Segment AE or FC in either one of those two triangles that we split off? Yes, no, maybe? No. It's right here. Well, that doesn't really help us with our two triangles, but it can lead us to something in our two triangles. Watch. Riley starts walking, she's walking right, she's standing on A, and she walks to F. Alright? Dustin's standing on C, and he walks to E. What do you know? They walk the same distance. Does anybody tell me how do we know they walk the same distance? Those two were congruent. What other parts did they walk that we know must be congruent? They both walked EF, didn't they? Anybody remember? We've been talking about all year long. What did we just use there? Segment addition postulate. Somewhere in our two-column proof, we're going to have to talk about or use segment addition postulate. Using the segment addition postulate, this added to this should equal this added to that, right? Are those two segments in our two triangles up here? So we know those two are congruent. That make any sense? Clayton, that make any sense? So that's a pair of sides, right? Now let's go back to the next given. Segment AB and segment BC, are they in our two triangles?
Yes.
Yeah. One's here, one's there. What do we know about those two then? So that's another pair of sides. Let's go back to the given again. Segment BE is congruent to segment BF. Are they in our two triangles?
Yes.
BE, BF. Another pair of sides, right? Is that enough to say the two triangles are congruent? Yeah, by what? Side, side, side. So we should be able to go through and prove this. Statements, reasons. Again, I'm trying to go quick so we can get to a couple other problems. First statement. Let's just go ahead and start with that hard one. Segment AE is congruent to segment FC. How do we know that? It's given. Now be careful. Is that a pair of sides in our two triangles? No. What we do next is we want to get to those two sides. And the way we're going to get to that is I'm going to write this. I'm going to write the first one, then I want somebody else to tell me what the second one would say. Segment AE plus segment EF equals segment AF. This plus this has to equal that whole thing. What would the other one say coming from the other direction?
CF plus FE equals CE.
All right. Now I'm going to turn it around just a little bit. I'm going to say segment FC plus segment EF equals what?
EC.
EC. She said the exact same thing that I wrote.
The backwards.
I just turned the letters around because I wanted this EF and this EF to look the same. Because otherwise Graham gets all confused, right, Graham? What do I know about AE and FC? What do we say up here in number one? They're the same, aren't they? What do you know about EF and EF? They're the same. Well, if these two are the same, these two are the same, what's that say about those two right there? Those got to be the same, and that's what I'm going to say next. Segment AF is congruent to segment EC. Oops, I forgot my reason up here. What was our reason on number 2? We wrote it down. Segment addition postulate. Number 3, maybe you missed this one, maybe you forget it. All you did there, when you know things are equal to other things, then you can substitute those other things in place of the first things, or however you want to do it. We're using substitution. Substitution. That was a pair of sides in our two triangles. Number 4. Where do I go to next? Help me out, Jonathan. Where do I go to next?
Up here. I'm lost, honestly. I was off.
So where do you think you go to next? If
Thanksgiving.
So AB, segment A. Convert to segment BC.
we know you never get lost when you're doing your homework or on tests or anything like that, right? So if you do get lost, you know, probably go back to the what? Given. How do we know that? Given. Was that a pair of sides in our two triangles? Yep. Do we have enough to say the two triangles are congruent?
No.
We're missing something. What are we missing?
The next given.
Segment BE is congruent to segment
Yeah.
BF. How do we know that? It's given to us. Is that enough to say the two triangles are congruent? So we go to the triangles. They gave us the triangles, so we don't have to match them up ourselves. How do we know those two triangles were congruent? Side, side, side. All right, look on the one worksheet, the one that says CPCTC at the top. We got 5 minutes. I can do one problem off of it.
Number 4.
That's what your homework's gonna start with. I'm gonna take it. I'm gonna do number 3.
Which one?
The one that says CPCTC at the top.
Easiest one.
You want me to, huh? No, this is probably the hardest.
There's
First one's the easiest one.